Be talking and not.
We've gotten deer in headlights. Hi everyone.
Good morning.
We needed more coffee. We needed more coffee this morning. Hi everyone. Welcome to Getting into Vault Part 8. Yay, we made it to Part 8. I think we'll have 11 parts to this eventually. I don't know. We'll see. Regardless, welcome. If you have not joined us before, hi, this is a live stream. We are going to be doing things the most difficult way possible. No, not the most difficult way, but what you're going to see on the stream is the imperfect path to setting up things, and in this case, Vault. We're not looking to make it 100% perfect. We're not here to show you the happy path. You, the chat, we'd love for you to participate. It is important for you to participate because sometimes you get to make decisions on the direction we take the stream. So good examples of this is like, maybe we introduce some chaos by turning off security groups because we could at the suggestion of chat. So if you want to participate in chat, we'd love to have you drop a comment, drop a question, drop suggestions on what we want to hear. If you are on LinkedIn, we may or may not see your comments coming into our feed. So just if we don't immediately answer them live, it's not because we are ignoring them. It is because we don't see them sometimes. We will be going back after the fact and answering questions. As you participate in chat, be respectful, be professional, and be welcoming. If you have questions about our community guidelines, you could check out HashiCorp.com/community-guidelines. With that, if you are looking at the other parts of the series and you're just not sure where the rest of the series is, we do have a playlist on YouTube. So if you missed parts 1 through 7 for some reason, you can check out hashi.co/getting-into-vault. And that will allow you to review all of the previous parts. So we do build on some of the other parts, so you may have to watch some of them in order to understand the current part. But today, we're going to talk about Transit and PKI Secrets Engine. Very exciting. Melissa, could you recap what we've done so far?
Oh, goodness. We've done everything from installing Vault to setting up HA and doing snapshotting and backups. We've done the AWS auth method, and we did static and dynamic secrets the last time I was on. But then last week, you did Kubernetes with Michael, and I was in the background supporting chat. So that was very exciting. And of course, this week is Transit and PKI Secrets Engine. So I'm super, super excited. For those of you who are joining us for the first time, I have not had hands on keyboard in production in about 10 years. So you will see me go slow. You will see errors and commands. It's there. It's just rusty. I've been focused on building technical teams and enabling technical communities instead. So that comes with the trade-off of not always having hands on keyboards. So when Rosemary said she wanted to do Getting into Vault, I'm like, yes, I will be your dummy and I will learn this stuff. And we're having lots of fun. So please.
I think you're pretty good. Honestly, you didn't need much. Like you maybe like some of the commands we need to type through, but like you're actually very good. So I mean, I don't see any issue. You're still technical. I mean, what is technical these days anyway? Let's be honest. Yeah, we can debate that all we want. But as a short note, because some folks did ask, so this is our approximate streaming schedule, subject to change. But we stream every Fridays, 8 a.m. Pacific. There will be no stream next week because Melissa will be at KubeCon EU. And so FYI, we are not streaming next week, but we will pick up part 9, which is performance replication and audit logging. We're going to go a little bit back to operations, and then we'll proceed with HTTP Vault Secrets and then Nomad. The Nomad one, I know folks are like, oh, well, we did Kubernetes. What about Nomad? I'm finding a Nomad expert to come and help because I myself have not used Nomad in a long enough time. So it is helpful to have someone who knows Nomad. So if you would like to join us, do let us know. We'd love to have you. Okay. With that, let's talk about Transit Secrets Engine. Transit Secrets and PKI. I broke these out into two separate secrets engines, not separate secrets engines. I broke this out into its own episode because these are some secrets engines that are not, I would say, not standard in terms of what you would consider credentials or things that you might want to protect. And in some ways, their workflow is a little bit different than a secret. So, Melissa, what's the workflow of getting a secret into Vault, right? You have two, which is the static and dynamic, right?
Right.
But what's the general workflow? So if you said, I have a static secret, what do you do to put it in Vault?
We did Vault Secrets list to see what was in there, but we do, I think it's a put, isn't it?
Yeah, you put it in key value. That's
Yeah.
it. You put the key and the value, and that's the secret. That's a static secret. And then we talked about dynamic secrets, which were database. Like one example is like a database credential, where it has a username and password, and we're dynamically generating them. And we just tell Vault, give me a database username and password. And Vault says, sure, here you are. And the dynamic secret uses a leasing system. When you think about certificates are indeed a dynamic secret. They have an expiration. In fact, they have a built-in expiration date for certificates. What do you know? Yeah. What do you know? And so if you want to issue certificates, you can use the PKI secrets engine in Vault. Wow. Yes. Excellent thought. But I guess I suppose, why would you want to use certificates? Why would you want to use PKI secrets engine to issue certificates? And it's I see. Melissa, would you like to answer?
Well, I mean, in another life, I used to manage web servers, and we had certificates, and we were very bad at tracking when those certificates would expire, and sometimes errors would come up.
Oh, yeah.
So for me, one of the things I would have done is use this to automatically take care of that in the background, so I didn't have to worry about them expiring and then getting errors and then getting angry phone calls from people who say, hey, my web page is down.
There you go, because no one remembers that a certificate's going to expire 5 years from now after you've issued it. So you can use Vault to help with that. We're going to do that today. You'll notice the process is going to be a little painstaking. We'll see how far we get through it. I think I'm going to swap the order a bit, and that we're going to maybe start with PKI and then do transit, because transit might be a little shorter, and I'm a little worried that PKI might take a while. But PKI issues certificates. TLDR. Too long. Didn't listen. I don't know.
Didn't read.
TLDL?
Yes, TLDL.
Yeah, TLDL. Okay. But Transit Secrets Engine. What is Transit Secrets Engine? Transit Secrets Engine allows you to encrypt data in transit, right? And really what this means is that, let's say you have some personal information that an application is processing. The application processes it and then maybe needs to write it to a database. You might decide, I just want to encrypt that information before it goes to the database, just to be extra secure, right? From maybe a security requirement or compliance requirement standpoint, if you want to be very vigilant about this, and you want to say like, okay, I'm going to use the same encryption key to encrypt data before it goes into the database, and an application needs to decrypt it when it takes it out and processes it from the database. It means that maybe you're better securing that data, right? And from a compliance standpoint, if you say, hey, someone potentially has compromised this personal identifying information, maybe what I can do is just revoke the encryption key and then re-encrypt with a new one, and make sure that no one can just use that PII anymore that's in that database. So there are a couple of reasons why you would use an encryption key why you would encrypt data in this manner. And so there is a secrets engine called the Transit Secrets Engine in Vault that issues encryption keys. And what it will help you do is that Vault itself will help you encrypt and decrypt the data. It does not store the data. It just helps you encrypt and decrypt it with the encryption key that it issues. So we're going to do a little bit of Transit Secrets Engine, but I think we're going to reverse the order, and we're going to start with PKI because we're going to do PKI in 2 ways. With that, we're finally going to share a screen, Melissa.
Okay, I'm ready for it.
Yes, this is Melissa's going to share her screen.
Indeed.
Mm-hmm.
Looks like I have to do the entire screen, so we'll do that. Sorry for the endless tunnel of noise there, but here we are.
All right.
And we're in the shell.
We are using Boundary. If everybody, if you haven't tuned into previous streams, we are using Boundary because this is a way for Melissa to pop into the Vault servers without, don't forget to source from opt vault.
Right. Yes.
This is a way for Melissa to just pop into the Vault server without me giving her direct access to the Vault servers. And if we accidentally show credentials on the stream, which is the case because we're doing a lot of stuff the challenging way. A lot of these, all of this infrastructure is revoked, but it's also secured as well. So yeah, that's why it's pretty much this. Basically, this environment is built to be is made to be rebuilt, but also so that it's secured. Okay, so this is a Vault server that has nothing in it. That's it. So we're going to start by setting up PKI. PKI issues certificates. You could use certificates in a number of ways. I don't know if chat wants to go through the number of different ways that you could use certificates. I guess, we could go through that, but I don't think it's entirely necessary. Let me pop the PKI documentation in chat for everybody's reference.
Woohoo.
That way we have it. Okay, so PKI Secrets Engine. Basically, Vault can act as a certificate, basically can act as a certificate authority and issue certificates. It could be root certificates, intermediate certificates, any of the above, right? Vault will generally be able to handle. The first thing we're going to do, we're going to do PKI in two ways. We're going to do Vault as a root CA, and then we're going to do an offline, what is called an external CA. So what this means is that if you don't really care about the certificate authority and you want Vault to issue one, Vault to almost behave as the certificate authority and issue the certificates, you can do that with Vault, right? So Vault itself will generate a root certificate based on its own certificate authority. However, there is a second configuration that you can do, which is called an offline root. And that's probably more practical, I would say, for an enterprise use case. You probably get your root CA from somewhere else. Whenever you get your DNS, whatever DNS you set up, you probably will be able to generate your own CA from that. And bringing that root CA, you can import that into Vault and then issue intermediates. Melissa, does that make sense so far?
So far, yes.
Okay. So we are going to do the first way first, which is we're just going to use we're just going to have Vault be its own self-sign, generate its own self-sign root, right? So let's do that first. Okay. So the first thing we're going to do is Vault secrets enable PKI, because that will enable this PKI secrets engine. Getting right into it. Okay.
Look, it's there.
Yes, it's there. So one of the things that with secrets engines, of course, it has a time to live. Melissa, what is a time to live? What is a TTL?
A time to live is how long that specific secret is valid for.
That is correct. And so if you do Vault secrets, read PKI, I don't know. We'll see. Read PKI, is that?
No, I think it's policy, right?
No, I think we have to do Vault read PKI.
Just Vault read.
No, maybe no. I need the configuration. Oh, whatever, fine. I need the configuration of it. It's fine. We'll just do it this way. So most when you enable the secrets engine has a default TTL. With certificates, you probably don't want to rotate your certificate every 10 minutes. That's probably not practical. The default for the PKI secrets engine, I think, is 30 days. Melissa, do you rotate certificates every 30 days? I mean, back in the day, did you rotate them every 30 days?
No, it was much longer than that. It was a matter of months.
Yeah. So you do want to tune your secrets engine with the TTL to match the issue time of the issuance of the the issue window of your certificate, the validity of your certificate. My goodness, words are hard. Need more coffee. My tiny
or less.
or less coffee. Am I too energetic right now? Jeez. All right. So the validity, right? We want to expand to match the TTL, right? Or we need to match the TTL to the validity that we want. So let's do vault secrets tune.
Ooh, this is a new one.
Yeah, secrets tune, and then dash max dash lease.
Oh, I'm getting ahead of myself.
Yeah, max dash lease dash TTL equals. Let's make it 365D. So 365.
So a year.
Yeah, let's make it a year. I mean, we could do it like 2 hours, but let's be practical. PKI. And then PKI. So then what this will do is tune the max lease to 1 year, and it will tune the PKI secrets engine to do that. So hit enter. You can exactly. Yes. So as you recall from previous secrets engines, we could tune the roles to different TTL. So remember, we did this with the database secrets engine. We did this with the console secrets engine, just as a way to explore. Remember, we took it from, I think it was like 2 hours down to 5 minutes, and we did it individually based on a role. Same thing happens. Remember, if you remember the setup of a secrets engine, it was enable secrets engine, enable pass in config for secrets engine, and then create a role that would generate the secret. And then you could set a TTL on that role. This is the same approach, right? So we can always tune this, but by default, we might just want to say, if you're using the PKI secrets engine, we'll just default it to 1 year for you. Okay. Oh, someone asked a question. Do you also show OSPF part to get proof that the certificate is still valid and not proof? We could try, not revoked. Yes, I think we could probably show that. But we'll see how much we can pull out of, but
I'm optimistic.
I'm optimistic. We'll see. We will see if we can get in depth enough. But I might move transit to another day, so we move just so we could do PKI.
So awkwardly here.
Yeah.
Before we were tuning things in config files, and now we're using this magical tune command. Is this something that's unique to PKI, or is this something that we could have done all along? We just didn't because we were doing it a more hard way.
We could do this all along, but most of the time we were doing it individually based on role. So in previous, it's not unique to PKI. You can always tune the max lease TTL. You can always tune the max TTL and everything else. Or you could always tune TTL, max TTL, and things like that. But the way that we've done it in the past is that we were individually tuning them per role. Because to be honest, from a scale standpoint, you might say that if you're doing dynamic secrets, like the database secrets engine, or some of the other secrets engines, you may have a different TTL per role, meaning per application. So one service might be able to handle a database credential rotation every 30 days, while another expects it to do it every year, right? In the case of PKI, though, in the case of certificates, right, most of them, at least I found, tend to be 1 year or longer. Some people might do 30 days. Some people might rotate them even more frequently. But most of the time, if they're on the order of 1 year, you might as well set a default one in this way when you tune the secrets engine. All right. So the first thing we're going to do is we are going to create a self-signed root. And why are we creating a self-signed root? Well, this is sort of the easy way to get a self-signed root certificate. Otherwise, you do have to bring your own. We are going to go through that setup. But there are some reasons in which you just want it to be easy. You just want a root certificate issued by Vault, and you want it just to be done. You don't necessarily want to use a root CA and then put in a signed intermediate CA to Vault. So we're going to do Vault write. PKI / root / generate / internal space common underscore name.
Typos.
Yeah, equals. You can put in. You know what? We'll do this way. Getting into Vault or something. Getting into Vault IO or something. .io. Getting into Vault.com. I don't know. Something like that.
IO. I like IO.
Yeah. Okay. Space. And then we don't have to do TTL. I'm since it's 365 days anyway, it just implicitly is going to be 1 year. So you can hit enter. Okay.
Oh, look at that.
Yes. So there is a certificate here. You're going to have to save a couple of these things. So copy that and save it. Since we've learned. Yeah. Okay. So there's a couple different things, right? We are not actually, this mount we don't have any authority information access fields. So we didn't configure anything there. So the result is that it might be a little bit unhappy with the certificate, but it's fine. It is it is a self-signed certificate. So.
All right. So now I'm going to stick that in my random file of notes.
Yeah, all of those are probably invalid now because I've spun up a new environment so many times.
Yeah. It's there we go.
Mm-hmm. Nice.
Awesome. Okay.
So we'll dig through some of this here. If you scroll up, there's a couple different important things to note. Is part of it. You have a certificate. There, certificate.
Mm-hmm.
What else do we have? We have the expiration.
Yes.
Yes, there's the expiration. There's the issuer ID, issuer name. I mean, the ID comes from within Vault. So, and then the issuing CA. This is a self-signed cert, so it's using its own CA. And then there's some keys, key name, serial number. So all this stuff is related to certificate information. For the most part, right? You can parse out all these fields, store them somewhere, and then use them wherever you're going to use them. But this is a root, right? So this is not something you would typically use in your application. I mean, you might need to use it if you want to, I don't know, if you want to reconstruct some kind of certificate chain or something, but for the most part, you're probably not going to use this in your application. So the next thing you're going to do is you're going to tell Vault to generate intermediates against this root certificate, right? This root CA certificate. So we need to configure in our workflow, as you recall, we enabled the secrets engine, and then we configured the secrets engine. So we also now need to configure the, we're going to look this up because CRL location, certificate revocation list location.
Okay.
So for this one, we are going to point it to Vault because that's pretty much where it came from, right? The CRL, it's a list that the issuer gives, right? So the certificate issuer gives you a list, and then it tells you which ones are the revoked certificates, right? So we are going to point it to Vault because Vault is the issuer of the certificate. So we want to point it to Vault. So we'll do Vault write PKI/config/URLs space issuing underscore certificates equals, and then we're going to point it to Vault. So it will be https:// and then sorry, not backslash slash yeah 127. We're going to do localhost 127.001.8200 /v1/PKI/CA, and then don't hit enter. So that's that space, and then CRL underscore distribution underscore points
Like the full word points or PTS?
Full word equals, and then same host. So http:// Oh my gosh, what is happening today?
Ah, it's okay. We're gonna get through this together.
I know. I know.
Almost everywhere.
Also, certificates are not my forte. I've like done this enough times, but then I'm just like, my brain just like always forgets.
Same.
CRL, not instead of CA. Yeah, not same, but CRL. Yeah. And so what this will do is it will tell Vault, since Vault is issuing the certificates, you're going to point the issuing certificates to the CA endpoint in Vault as well as the CRL endpoint in Vault. Important to do it if you decide you're going to update the CRL location to somewhere else and the CA location to somewhere else. It's going to be important to configure, but for the most part, you're going to probably point them into Vault. Hit enter.
When would you point it somewhere else?
That's a good question. I guess if you have if you have a root certificate somewhere, right, or you are setting up Vault to issue intermediates, right, you might decide to point this somewhere else because it's not the root. But most of the time, I find myself pointing it to Vault. Now, someone else in chat, if you do point it somewhere else and you're using that, do let us know because I am curious. But I am also going to just say that I am not a certificate expert. So if anybody does have more expertise in how they configure their certificates, please drop a note.
Please share. Yes.
Please share. We do want to hear from you.
Sharing is caring.
Sharing is indeed caring. I do see a question. If we have not configured it, can we see the existing TTL time? So we did configure it. Yeah, I think we did configure it.
Yes.
But it's not, I guess that we could show the default TTL time. We configured it to 1 year. So in config file, I don't know.
Are we looking to open up the config file and see what's there, or?
I think it's asking mostly like, what is the current TTL? What is the current TTL? If you are, Melissa, there's a lease, right? There's a lease ID or something in the certificate output from Vault.
Let's check that.
Or maybe not.
No, there's an expiration.
There's an expiration, yeah. So that will tell us when. Yeah, Vault read sys mounts PKI config should show the config on PKI. Let's give that a try. Thank you, chat.
Okay, 1 second. Vault what?
Vault read sys/mounts.
Okay.
/PKI/config.
Just that.
Yep.
Boom.
There we are. Thank you, chat. Much appreciated. So config has nothing. So default least TTL is 0. But max least TTL we've updated to 365.
So 0 in this case is just infinite.
Mm-hmm.
I would assume. Okay. No expiration.
But I guess the max least TTL is really the more important one in the case of certificates.
Yeah.
All right. I'm just going to pull this up and make sure I follow along again. Okay. So we've configured that now. And then, of course, after config, we always make a role, right? Our role is going to generate a certificate based on, generate an intermediate certificate based on the root. Sorry, not intermediate. It will generate a certificate based on the root that we have. But we also have to tell how the subdomains that we're allowing, as well as any other attributes that we're allowing to generate the certificate, right? So it's not like we could just magically generate a certificate. We have to tell Vault, the Vault role, what we're generating it for. So because we configured our domain that was getting into vault.io, we need to tell the role that we allow any subdomains, right? So it could be Melissa.getting into vault.io or Rosemary. Getting into vault.io. To be issued for that certificate given CA. However, you can't just issue a certificate for everything, right? So Vault expects you to restrict the kinds of things that you're going to set up, the kinds of certificates you're going to be issued. So we're going to start with that. I'm going to pull up the API because I think it's probably better. Like the documentation is massive for this, by the way, folks. So as a heads up, you might get a little bit confused, but let me pull up the role information. Oh, I forgot. We could have done Acme too. Yeah, that's okay. Hold on. Generate certificate. Where's the role? Hold on. Read role, create update role. Okay, here we go. I'm going to post this in chat. So PKI secrets engine API. Okay. All right. So if you do want the full list of attributes, there is a large list of attributes that you can set, including allowing localhost, or allowing domains, allowing bare domains, allowing subdomains, allowing glob domains, wildcard certs, like IP sans. This is important. Like if you're configuring console, for example, using Vault as a CA for console, service mesh, or any service mesh for that matter, if you decide to do so, you will have to maybe configure IP sans or some other things, right? So the point is that there are a lot of attributes that you can put on the role to ensure that it constrains the type of certificate that you're going to issue. Or not the type, but the attributes of the certificate that you're going to issue. So if someone wants to get a certificate from Vault, they need to have the right set of attributes in order for them to get the certificate, a valid certificate in the first place. So let's do this. We're going to do Vault write PKI. Oh, let me move this in. /issue/ name of the role. You can Melissa.
We're going to pick on Chris today because he's in the background helping us out.
Yes. Chris, and then we're going to do the common name.
Common name.
Oh, no, wait. Sorry. I skipped a step. Go back. Go back. PKI roles. PKI /roles. Not role.
Yeah. Typing is fun.
Holy cow. Today is just like a... Okay, so then Chris. And then space. Allowed _ equals, I think it was getting into vault.io.
Yes. Mm-hmm. Does it matter if I have to keep camel case every time I do this?
No, I don't think so. I don't think it matters. Allow _ subdomains. This means that anybody who requests a certificate for a subdomain is going to be able to get a certificate. So that's why we do this. Equals true.
No caps on true.
Mm-hmm. And then we're going to do the max TTL. This means that when you issue the certificate, you could also set even, add, like I said before, you can add more restrictions on on the certificate validity of a certificate issued based on the CA. So the CA has the certificate authority has a validity of 1 year. The certificate may have something shorter. So Melissa, you can choose to make a shorter lived certificate if you would like, or you could just not set this and we can have 1 year. I leave it to you to decide.
Let's do shorter.
Okay. You want to do half a year, 2 hours?
Let's do 90 days.
Okay. Equals 90D. There you go. Okay. Hit enter.
Okay. Look at all this.
Look at all this. Now you have a role called Chris. And you notice these are the giant pile of attributes that you can set. So you can set a lot of these values for any specific kind of any attributes in your certificate that you deem important or deem useful for the usage of that certificate. So some of these things that you will probably want to configure, include country and, allow in terms of the allowances that you can make for the certificate, right? There's some things that you're probably going to want to add as well. So there's a lot of information here, but you can also adjust the keys. You can also adjust, a lot of other attributes as well on like locality and postal code and things, all the important things that you would typically configure as part of a certificate.
And it converted my days to hours.
It does, yes. The internal systems will convert them to a singular time unit. All right, so now we are going to issue a certificate. So if you do vault right, PKI/issue, and then you can say Chris, space common _name. We should be able to issue a certificate with the Chris subdomain. So, or we could just do the getting into vault.io or one way or the other. But
I assume it's going to be like this.
yeah. Mm-hmm. Yep. There you go. Yep. Enter. Aha.
Cool.
Not allowed. Oh, common name not allowed because it's a root. So we'll just do getting into vault and then we'll set up the intermediate. Huh? All right. What did we set wrong? Let's see. Okay. So we allowed subdomains. That should be fine. Allowed domain. What was the, maybe it has to be camel case. It has to be camel case.
Okay.
Yeah. So camel case.
We'll
Chris
check it
not
out.
getting into vault if you want. Chris not getting. Pretty sure. Yeah. And then camel case that. Maybe it does have to be camel. It does have to be camel case. How interesting. Thought it wouldn't care that much. Aha. TTL would be a result of not after that is beyond the expiration of the CA certificate. Aha.
But the CA certificate is supposed to expire in like a year.
I know. Well, let's check out what's going on. So what's the expiration of that CA certificate?
It gave a really weird value on it. Like
it's probably epoch time, right? So
well, maybe. But yeah, it's this year, 17/13/289/35.
Yeah, so convert that. I think pop online, convert that.
So literally open a browser and do epoch time.
I mean, I can hold on. Let me leave it up on the screen. Okay. That way you don't have to do no one has to see the inception. Like
no. Oh yeah, that's right. But I mean, I can technically open Safari.
Yeah, all right.
Or another browser. I mean, I assume it works.
What is life? This okay. April 16th. Yeah. So interestingly enough, I think somehow the TTL, it's got a interesting. Yes. So somehow it didn't pick up the TTL that we did set, right?
So we need to set a new one.
The max _TTL. Why would it not pick this up? I feel like maybe the documentation is not 100% correct. Let's see.
Sounds like PR.
No, I think we need to configure it on the role, unfortunately.
Oh.
Did we? Okay. We did configure. Wait, we did configure it on
we
the role.
did, but we issued the certificate before we created the role, right?
Yeah. Well, yeah. we issued the CA certificate before we created the role. So it's fine. Let me just see the example. If you go to 72H on max TTL, does that fix it? Okay. So
it's in as 72H.
Okay. So let's see if we issue it now.
This time it works.
So what did it do differently? I guess it
just did not like that 90 days.
Okay. TTL 7. Okay. I think. Okay. So I guess I don't know what's different though. 768 hours. So 768 hours is 32 days. So I think what happened was that our max, so because we set our max TTL to 90 days and our default TTL was, according to this, 30 days.
Okay.
Yeah. So somehow it was not quite going through. So I think that the max TTL must match the default TTL. So that's one thing to know. Yeah. So the default has to match the max, or at the very least has to, yeah, I think it has to match the max, it seems. Because if the default, what it does from a UX standpoint is, if the default is, because we're setting max TTL, right? So if the max TTL is less than the default, it will put the max TTL as the default value, which is why we're setting max TTL to 72 hours. Is a forcing function to basically tell Vault to configure all of the TTLs under this PKI secrets engine with 72 hours, right? So then it matches the default to it. But the default is 30. So we have to either set it to 30 or less, I guess, or set both TTL and the default TTL plus the max TTL to be the same.
Okay.
So we can try this with the role. Let's reconfigure the role. So if you go back to configuring the role, Chris's role.
Yes.
And we set, I think TTL. Is TTL one of the attributes? Let me look. It's TTL, I think. Is it default TTL? I'm looking at the giant list of configuration values. One moment in the API. TTL. Yeah, so we do TTL. So TTL. Okay. TTL equals 90D, and then space max underscore TTL equals 90D.
There we go.
Okay, and then now if we issue.
Do we want to do the same common name?
Yep. Okay. Could it be that? Wait. Okay, I think our certificate. Hold on. I don't think we got the CA correct. I think the CA is 30 days.
Okay.
We didn't actually set it to
that tracks
1 year.
given
Yeah.
the message we're getting.
Yes, I think we may have as it's a root. Okay, so this is where the problem is. Okay, so let's go back to if you go to Vault Secrets Tune, and then we'll do I guess default least TTL. Let's see, default least TTL. Let's see if this is a valid command value. Default least TTL, and then we'll do 180 days for that. So we'll do half a year. Let's hope this works. Okay, so this should tune it. So there's a default least TTL. And then let's do the right PKI issue with that. Yeah.
This one.
Yep.
Yeah, because the certificate hasn't changed.
Right. All right. Let's reissue the certificate then. Going to do vault write PKI /root /generate internal. So we'll go back and regenerate that and probably recopy it.
This one here?
Yep.
Okay. All right. Let's recopy it.
After all, this is why we show the sad path.
Yes. Also, I honestly wouldn't learn if we got it right the first time.
I know.
The trauma induces better memory.
That is okay. Pulling up. I have too many.
I have no idea why this whole thing's a link. It's being silly.
It's fine. It's fine. It's all right. Hopefully this means if you go back to the expiration time, if you go back up to it, scroll up, and then
this guy.
2, 3. That is that is September. That is looking a little better. Okay. All right. So we fixed that. Now, if we issue the certificate, theoretically, give
it to us. Nope.
Do
we have to get rid of the old one?
I guess we probably do. We probably have to delete the role. So if we do vault delete PKI /roles/Chris.
Chris, you're about to get deleted. It's a very sad day.
Either that or somewhere or another. Okay, yeah, hit delete. Okay, and then we're going to redo it. So it's vault right PKI roles Chris. Yep, there we go.
Everything else good?
Yep, everything else good.
New role.
Okay, and then now let's reissue the root certificate.
And
it worked. Oh boy. Here we are. Okay. So we have a CA chain. It is the root CA. It is using the root CA. So you're only going to have, well, I think one certificate in the chain. It's kind of hard to tell, but it's fine.
There we go.
Yep. Okay. So important thing to know is that it will have the it will expire in 90 days, or sorry, 30 days. That was we set it to 30 days. So this is a root certificate, and it will expire in 30 days. That's pretty much the important thing to know. The private key and the certificate are specific to the role, but if you do the issue again, Melissa, if you run issue again and hit, yeah, you'll notice that it generates it again and it's a new one, right? So the idea is that you can issue any number of certificates under this root CA that you need. So there, for the most part, you know, we've done our first step, which is to get a root certificate. But you're more likely to issue intermediate certificates. You're not really going to set up something from a root certificate, root CA. From a security standpoint, you're probably going to you're going to have intermediate certificate authorities that issue intermediate certificates in various, for various reasons. But we're going to set up what is called an intermediate CA in Vault. So what this means is that we are going to use the root that already exists and use it to sign the intermediate. So we have a self-signed root that's in Vault, and we're going to use it to sign the intermediate CA. And then we'll issue certificates based on that intermediate CA. So we're going to go through this again, but we're going to do Vault secrets enable. Space, we're going to change a little bit, and then we're going to do dash path equals PKI underscore int, and then PKI. So what this means is that at the PKI int mount path, we're going to create a PKI secrets engine for the intermediate certificates. So you can enter. So one thing to know is that it's not one PKI path issues every single certificate, and you can just configure a different certificate for each path. For one single path, you have to do individual paths for the individual CAs. Yeah. Yay. Okay. So now we're going to once again do some Vault secrets tune. We're going to do Vault secrets tune. And then we'll set the default dash default dash lease dash TTL equals 365D space max dash lease dash TTL. Don't forget the dashes, all the dashes, even before the max. And then 365D, and then PKI underscore int. So we're just going to do 1 year for the intermediate CA as well. Okay, so next you need to generate a certificate signing request, right? So generally when you have intermediates, you want a root CA to sign it, you need to generate what is called a CSR, or certificate signing request. So we're going to do vault write PKI underscore int,
Yes.
/intermediate /generate internal, and then common name will do Chris getting in. Oh, we already issued a subdomain on it. Whatever, it's fine. We could just do Chris getting into vault.io or something.
This time we'll do lowercase.
You do want to do it. You do want it to match the common name of the root, though. So
okay. So we have to.
Yeah, you have to do case.
Gotcha.
Yeah, note to
We're
self.
still using that root because it's intermediate.
Exactly. Yeah. And yeah, you know what? Just to make it easier, if you can pipe that into a file somewhere so that we have it. Just do it somewhere. I don't even know. Yeah, something.
There we go.
Yeah. Okay. So it doesn't have any information, but if you look at chris.cert,
what's there?
Okay, you'll notice there is a CSR. So we are going to take that CSR and we are going to put it in a file. So if you can copy the CSR from the begin certificate request to end certificate request.
Just the middle part, not the actual begin?
Nope, you do need the prefixes of begin and end. Yeah.
Okay.
Because it is a file it is a valid file. So you're going to copy that and then you're going to put it in maybe like PKI_int.csr. So you can create a file. PKI int.csr. Go. Okay, paste that in there. You can save it. Okay, so once we get a certificate signing request, this means that we can use another CA, specifically the self-signed root CA that we've generated in Vault, to sign it. And this is going to be the workflow if you want to do any intermediate CA in Vault, which is probably most of the CAs you're going to be setting up. So we're going to do Vault write PKI /root /sign-intermediate space CSR equals at PKI_int.csr. So when you define the CSR, you can pass in the file. And then space format equals PEM_bundle. So PEM_bundle. And then we're going to set the TTL. TTL to 365, something like that. Yeah. Since it will match the root certificate authority and everything. So if you hit enter. Okay. What this does is it means that it generates an intermediate CA.
Woohoo.
So this means that you have now an intermediate CA. If you look at the chain, right, there's going to be, it's going to start with the intermediate. And then if you scroll down, I believe there's a second set of certificates. No, slow. Yeah, there you go. So you'll notice end certificate, begin certificate. So it starts, there's an intermediate CA, and then the chain has a root CA with it. So all of that is information that's there. So now that we've done that, we of course now need to go back to setting up the CRL location and fixing the issuers, right? So, oh wait, we missed a step. Hold on. Okay, here we go. So since we have that, we do want to save that output somewhere into a file.
Okay.
We will need the certificate out of that.
Okay.
So if you copy the certificate out of that giant list of...
Which certificate?
It should be a certificate field in there.
Oh, here, this guy?
It's all yellow, yeah.
Oh. Silly, silly. One moment, please. We will fix this. Okay. So whole thing, including the word certificate, or just begin certificate to end certificate?
Everything but after certificate. So there's 2 sets of begin and ends. You'll need both. So copy that whole body. So the reason why is that it is the certificate chain. So you'll see this is the intermediate CA, and then it has the root CA at the second part of the other begin certificate. So you need all of that in order for it to be a valid CA.
But not anything past end certificate.
Exactly.
So we're here.
Yep. So copy that. And then you're going to put it in a file. You can call it signed cert.pem, something like that. What are certs? It's just this whole chain of things. Okay, here we go. There you go. That's a lot of information. Okay. So once we've signed the intermediate with the root CA, now we're going to take this certificate, this intermediate CA that was generated by Vault, and set it into the secrets engine. It doesn't automatically set it for you. It just generates the intermediate CA, but you do need to tell Vault that it is going to use the intermediate CA in the secrets engine going forward. So we're going to do Vault write PKI underscore int / intermediate / set dash signed.
Set dash signed.
Space certificate equals, and then at signed cert.pem. And what this will do is it will say, okay, in this secrets engine, you're going to set my CA to be the one that I've generated from the intermediate CA that was generated by Vault and signed by the Vault root CA. So that's pretty much the telling the secrets engine to reconfigure itself to be an intermediate CA with the correct intermediate CA.
I need this stuff?
No, I don't think so. It's just the issuers and mappings and things like that. We probably don't need it right now. Okay, so after this, right, then it follows the rest of the PKI workflow where we configure the CRL location. So if we do vault write PKI underscore int / config URLs config / URLs. You could probably find this command in the within your history, Melissa, and just change the file path to PKI int and not PKI. So not file path, the API path.
Yeah, it's way back here somewhere. Should be right around here.
Yeah, there we go. And then just change it to PKI int. And then
everything else is the same, or do I need PKI int everywhere on the URLs too? Oops.
Yes, on the URLs as well. So everything that says PKI, you change it to the mount.
That makes sense. And it's probably way shorter for y'all watching than to listen to me type all that stuff again.
Yeah. Way easier. Okay.
Look at that.
Yeah. So now it's been reconfigured. Excellent. All right. So now we're going, after all these shenanigans, we are going to create a role again. This time we're going to, with the intermediate, did you do Chris getting into Vault?
Yes.
Okay. So we'll need to set the intermediate to do Chris getting into Vault, right? So we'll do the same command except change PKI mount to PKI int mount. Yeah, so we can probably just find it again. The role. Yep.
There we go.
Okay, so the role, we're going to change the allow domains to Chris getting into Vault.
Yep.
As well, so we're just going to be consistent.
Poor Chris.
Okay.
That's it?
Yep. Okay. So now we got that. Now let's issue a certificate based on that intermediate CA. Oof. I need like a bingo card or like a tally of how many times I say certificate and CA in this. Vault right PKI underscore int /issue / Chris. And then we'll do the common name. You can do common name. And I think you could probably do chris.gettingintovault.io, or you could do dev.chris or something. Whatever you feel, you could do a subdomain as long as it's valid. Yep. Okay. Could not fetch the CA. No issue. Default issuer. How fascinating. I thought we set up some default issuer issuing certificates. Did we miss something? PKI int. Cannot fetch CA certificate. Was one set. Okay. We issued one.
Mm-hmm.
Okay, so we got the certificate signing request. We did that. Did we signed the intermediate? We got that certificate back out. So that's good. And then we should have, I wonder if we do vault read PKI / intermediate.
PKI/ or PKI underscore?
Can you actually go back in history and just check if you can look if you look for the sign intermediate command?
This one?
No, not the set sign, but the sign intermediate command. Okay, so we did do that. We got the root. That was correct. Sign intermediate. Okay. All right, so then set signed appears to not have worked because it looks like it didn't properly set the issuer. So PKI in intermediate set signed certificate at signed certificate.pem. We do have a signed certificate.pem, right?
I mean, we should.
Yeah, just check cat signed certificate.pem. Okay, yeah. That does the 6. Okay. And then if you could read PKI underscore int config /urls, if we could do vault read on the PKI int.
Yep.
Config. Okay, so that looks right. C PKI in CA, PKI in CRL. Huh. All right. Allow subdomains, the roles. All right. So try it again. Issue.
Oh, wait. This one.
Could not fetch CA certificate. No default issuer currently configured. Oh, fascinating. Okay. Default issuer. Let's double check. We are doing some quick troubleshooting. Just verifying. Let's double check. Let's see.
Well, there's an answer on the forum that we can put up when we figure this out.
Yeah, I know.
So there's a similar question around Terraform and the Vault provider on the forum.
Wait. Okay, so issuer ID. So we do need that issuer ID, I guess, from previously. Okay, so CA bundle, when import CA bundles, you can see new issuer at PKI. When I see PKI config issuers. Okay. Can you do vault read PKI/config or PKI int? Sorry. Yeah, /config/issuers. I see. Well, this is probably where the problem is. There is no default issuer. So let me think. There should be an issuer ID that came out of, because I think we had an issuing CA, we probably want to match it to the ID of the issuer that came out of the root CA. I assume.
Out of the root CA. So that's going to be in our little cheater thing here. And I'm assuming it's probably going to be at the top, but maybe it's in that issuing CA. So issuing CA is what we want.
Well, we want the ID. There should be an issuer ID under the root somewhere.
Okay.
Maybe.
Issuing CA in certificate. There's a serial number.
Maybe it was the one when we did set signed. Can you run set signed again? I think it actually had the issuer ID in there.
Okay.
If you run set signed, or you scroll back, if you scroll back up through it, maybe there's an issuer ID in there. Oh, no imported issuers. Existing issuers. There's an existing one.
Okay.
So if you grab that one, that ID, basically we just need to match the ID to, it looks like, based on this. Sorry. No backslash.
Oh, right. For the first one.
Yeah. But let me check the endpoint for this. Issuer. I think it's because we're using issuer ref, which is update issuer ref. Okay, so yeah. So vault write PKI int issuer / default. And then space, issuer underscore, wait. Sorry, I'm checking the fields.
Yep.
I'm in the API doc. But for those who are not tracking along, I'm in the API docs. Provides a name to the special reference to an existing issuer, the literal string default. This is part of the request. Issuer underscore name, I think. Is that it? Fix issuer. Issuer ID as reference. Yeah, let's see. Maybe it's, I think it's issuer name, that, but it probably won't be that. We'll see. No default issuer currently configured. All right, let's go back. Default issuer. Read issuer default. Can you actually vault read PKI/issuer, PKI int /issuer /default?
Maybe.
Yeah, let's see.
Nope.
No default. Okay. Configure default. Does it have it on PKI? Can you check on PKI, the root?
Yes.
Okay. So it does have it there. Issuer ID. So interesting.
It's a different ID than the other one has.
Yeah, which is fine because I think it's the issuer is coming from the root.
Yeah.
So let that there, and then let me see. How did this get configured? I have it configured in Terraform, which is hilarious. all of this I configure through Terraform. So,
Yes.
okay, well, apparently I never configured an issuer for it. So there's that. 1 second. Set signed. Yeah, I guess I never configured an issuer for it, but it still worked. So I wonder what I did. Let's see. For example, use the vault write in order to reissue the following command: vault write issue. Replace the my role in which the certificate was issued and adjust parameters. Yeah. So right now, what we're having a trouble with is that there's no default issuer set for the intermediate. And so we are trying to figure out how do we set the default on the default issuer on the intermediate. So I don't know. Right now, we've already done the set signed, so that's fine. But we need to figure out a way to set the default issuer for it. Yeah. So set signed left. Oh, look, there's an issue open. Set signed endpoint is, yeah, default issuer doesn't get set. So that's interesting. That might be a bit of an issue. So let's see. Okay, let's double check. How do we, you probably want to fetch the certificate, the serial number. Yeah, we just need to set the default certificate somehow. So, oh, we do have that. Hold on. Generate root CA. We have the issuers. I'm pulling up some more information here. URLs, we have that. We have issuing certificates. Okay, so the intermediate CA, we do need to pass in an issuer name. So if you do vault write PKI underscore PKI int intermediate
/ intermediate.
Yeah, / intermediate / general / internal or / whatever. Yeah, internal. Yeah. And then the common name space common name, which was we could do whatever. So the common name doesn't have to be the DNS, right? It could be like intermediate, right? So getting into vault.io intermediate if you wanted to. It doesn't have to be that. And then it says issuer name under issuer underscore name equals Chris. We'll just do Chris because, why not? And then you'll want to put that into the CSR. So into the what was it? The PKI and CSR, not the cert, but the CSR. So I think we called it PKI underscore CSR. And you'll don't append it. Just do one of those arrows. Int CSR. Okay. Unsupported path. Generate, not general.
Okay, yay.
I think we might end up. Yeah, I know. Thank you. Yes, and someone said other fantastic Chris says great issuer name.
Unrecognized parameters under issuer name.
Okay, well then let's see intermediate general. Let's see what is an actual valid one then, because then I think I need to go and dig through docs because I don't think they're all updated, unfortunately. Okay, let's see. Do we have an issuer underneath this? No. Okay, well then, this is very, very challenging. Could it be that we might have broken it a little bit? I don't know.
Breaking stuff is cool.
Breaking stuff is very cool. I'm digging through API docs right now, so there should be a way to set the issuer.
I'm just gonna mess around.
Yeah.
And see if I can find it while you're looking. So we're gonna see a lot of wrong things done.
Well, if you do help, maybe we get. I don't think we're gonna have any information though on the field, but
help. Field.
No, I don't. Unfortunately, we have to do the API reference. So, issuer name. Okay, we're just gonna look at all issuer ref. That's all Acme. Give me a second. That's all Acme still. Issuing certificates. Issuer ref. Issuer. Huh. Issuer reference. Issue name. That is not what we're looking for. I want to set the default one. Let's see. Okay, so it's an alias of import. We're double checking some things. Two peers. Her problems I use solve naming for a general. So you have to make a map and then make issuer name only work. How do we set the issuer name? I see. Yeah. I think it's the intermediate. We basically have to set some in something. Generate the intermediate command. Okay. You know what? I think, wait, Vault PKI. Can you check Vault PKI? There should be a command line, that CLI command Vault PKI in newer versions of Vault. Okay, this might actually make it a little easier. Might help us a little. Okay. Yeah. Okay. So Vault PKI issue. Yeah, because I think this means it actually sets up, it does it all internally for us, so we don't have to do it. So let's do issuer -- issuer _ name. I'm gonna do Chris space PKI / issuer and then the issuer ID of the root CA that we had.
Did I leave that paste? I think I did.
I think that's another. That's the one. That is the one we want because we issued two different ones, right? And then we saved it.
Yeah.
Yeah. So that might be part of our issue. Space PKI _ int, and then space common _ name equals Chris dot getting into Vault. And I assume the IO and this, I assume it has allow subdomains, but we'll see. I think if you do allow _ subdomains equals true.
Maybe true.
I hope so. Maybe you don't need it though. I don't think you need it. Maybe not. Yeah, you can actually remove that. Let's just remove that. Yeah, remove that for now. And then that I think should be all. TTL. TTL, what do we want the TTL to be? 90 days? Was that what it was? Yeah, 90 days. Okay. Okay, so this is a problem. All right, let's go back to the PKI issuer. So let's I think it's the wrong ID. So if you do vault read PKI, vault list PKI issuers, vault list PKI / issuers. Yeah, there we go. Okay. So neither of those are the correct ID. So let's do 300. Or the one that we passed in was the wrong one. So let's do 300 instead. That was the one that we saved. We ran it twice and then we saved the first one. So let's get that root CA certificate and set that there. So note to selves, use the PKI in PKI command line. I think if you use the PKI command line, it solves the problem. If you were doing it by like the CLI commands, which we were doing, I think that there are some missing steps there. So we probably should go back in documentation and look at it. But this looks like it's actually correct. Yeah, it does look like it's actually correct. So this means what happened is that we took we told the PKI, we told the intermediate to be signed to intermediate. Basically, in this whole step, we omitted the CSR from the intermediate, and then we omitted the signing of the signing and then setting the signed certificate back into the intermediate. So we basically omitted that command entirely because this issue command handles it all for us. So that means that we don't have to do it ourselves. Now we should be able to write a role for PKI int /roles /Chris. And then we're going to need to define issuer ref. So issuer _ ref, and then copy the issuer ID that we had before.
This one.
Yeah. Mm-hmm. And then allowed _ domains equals Chris.getting into vault.io, that whole thing again. And then allow subdomains equals true. And then max TTL 90 days. I guess, yeah, 90 days. It's probably fine. Yep. There we go. Okay.
Enter.
Yep. Hit enter. Okay. So now, after much back and forth, you'll have noticed that now it has output a role. And now we should be able to request intermediate certificates from this intermediate CA now. So yeah, vault write PKI _int /issue /Chris space common _name. You can do dev.chris.getting into whatever. And then TTL equals 30 days or whatever, 90 days, whatever you want to do. As long as it's below 90 days.
Yes.
Okay. Hit enter.
Look at that. It's
there. And now we have a certificate. Important thing about the certificate, if you look at the CA chain. So CA chain, there's the root. If you go there, and then there's the root CA, the intermediate CA, and then there's the actual certificate itself listed there. So a lot of that is all there. You also have the issuing CA as well, which is going to be the intermediate CA that you set up in Vault, as well as the private key. So that's that. This is the tutorial with all the updated commands. I'm gonna make a note to in the documentation that we're going to need to update the documentation to also include issuer for the intermediate. It does require the ID. So if you are doing this with not using the Vault PKI command and you're using the CLI commands, you will need to similarly take the issuer ID you will need to take the issuer ID of the root CA and then pass it into the intermediate CA upon signing. So unfortunately, that was a bit of a back and forth, but you will need to pass it as part of your issuer ref. So there is an issuer ref. There's an issuer ref attribute that you would pass in, and you will need to make sure you do that. So make sure you have that when you sign your intermediate. So that should actually work. We just use the PKI issue command to make it a lot easier to do this. Okay. Melissa, any questions so far?
No.
Is your brain like exploded?
Not entirely, no. I'm actually having a really good day given like seasonal things.
Yeah, there you go. Okay. In chat, I folks have been asking and providing commentary. Thank you. So that has been very helpful. We're going to do the next thing, which is, so what we did was we got a root out. We had Vault generate a self-signed CA, right, for us. So it generated a root CA for us, and then we use that root CA to sign. But what if we have not a root CA, but any CA that we wanted to bring into Vault, and then we want to allow Vault to issue intermediate certificates, right, for it? This is the more likely scenario. Part of the important thing about this scenario is that you are bringing your own certificate, right? So you are taking your certificate that is part of your org, and then you're going to bring it into Vault, right? And Vault will issue, we're going to do the same process from the intermediate CA onward. So, right, we're going to take that root, and then we're going to use it to sign an intermediate CA, to sign the intermediate CA generated by Vault, and then Vault will issue certificates based on the intermediate CA it has. And you can use these, you can keep doing this across any number of levels of intermediate CAs you want. So as long as you are able to reference the root, offline root or root CA, and then any previous levels of the intermediates that you have, for the most part, you can continue to allow Vault to issue any number of levels of intermediate CAs. And so what we're going to do is we're going to start back at the beginning, but we're going to imagine we have a root certificate somewhere, right? So there's a fantastic example that was done on offline root CA, a fantastic tutorial done for offline root CAs. I'm going to post it here, and we're going to go through that process just to make things a little bit easier for ourselves. We're going to walk through it, and we'll see. Maybe it's good, maybe it's bad. We don't know what's going to happen. Okay, so the first thing we're going to do is generate a self-signed certificate. You laugh, but apparently that's a lot harder than you think. I think the example uses cert strap, which basically creates self-signed certificates. So we may need to download that.
Okay.
Let's see, cert strap. Do they have that on Ubuntu? Otherwise we have to build it, which I don't really know if we want to, but otherwise we're going to have to do my commands, which are my sad giant pile of OpenSSL commands. It'll be fine. Okay. All right. Okay. Can you list files under optvault? Optvault PKI. Optvault PKI.
There we go. There
yeah.
too.
So I did not use CertStrap when I originally did this. So I was using OpenSSL. I'm starting to think that it's probably better just to use CertStrap for the folks who are here who are like, what is going on? But you know what? We're going to just use the commands in here. So Melissa, if you could open offlineca.sh. We're going to copy some commands from it. We're not going to run it as a script.
Oh, right.
Yeah. So just open it. Yeah. Okay. Couple important things. There is information that basically what this will do is generate offline root CA for well, not console servers, but it will just generate offline root CAs. So the relevant ones here is that going to be, we probably want to make the root a root directory. I would just store everything for CA key, CA key, and CA cert. So copy the make directory opt vault PKI root.
Okay. If I remember right, that's how we do it.
Yep. And you're going to run that in your terminal. Okay.
Nope. It's fine. Actually,
it's
we're
okay.
just gonna kill that and
Yeah.
entirely. Like, okay.
Yeah, this is this took a while to make to figure out.
Yeah.
Because I was like, I remember trying to figure this out, all these commands out with OpenSSL was a pain.
What were the options?
Yeah, it was opt vault PKI root is fine.
But
that's good.
Wasn't there a flag or
dash
something?
P. It was -P if it doesn't already exist. Yeah. Mm-hmm.
Yeah.
Okay, so if you go back to that script and then okay, so you're going to do OpenSSL gen RSA. So go to, I think, after that line. We're not going to touch the intermediates because the intermediate folder, because right now we're just going to generate the root. So let's do that first. So what this will do is generate a CA, a certificate key, a root CA. So this will generate the root CA. You can put any passphrase as long as you remember it, Melissa. As long as it's short, because you're going to be entering it a million times.
That would have been better to know a second ago.
You can always reissue. You can always run the command again. Just run the command again, and that way, no one has to see us.
No, it's my secret.
Okay. All right. Okay. So then what we're going to do is, if you go back into your script again, we're going to do that second line, open SSL request. So what this will do
the
is
whole thing all the way down to root CA.
Yeah, so this will generate a CA certificate. One thing to know when you paste the command, one thing to know is that there's a common name, example root CA. So we're not going to be using domains or anything. We're just going to be using a common name that just a very descriptive common name that describes exactly what it is. So this is the example root CA. This should hopefully work. I didn't test these commands. But it has a 10-year validity on it. Yeah. No value for subject names. Yeah, it's a country, state, or whatever. We didn't actually put anything in. It's fine. So it's skipping it. All right. So next, what we're going to do after that is we should hopefully have a CA key and CA cert under vault PKI root. You can ls vault PKI root and check that out.
Okay, I'm gonna copy this.
Don't do anything yet with those.
Yep. So
Yep. And if you want to do open SSL X50 space X509 lowercase x.
Yes.
Or X509 space in space dash in, sorry, space dash in space /opt/vault/PKI/root PKI/root CA.cert and then space -no out space -subject and then space -issuer. And let's hope this command works. Apparently it does not. Sorry. Oh, in, not n, in.
Like IN?
Yep, in. Okay, so you'll notice we didn't have, and we had the org, we had the organization unit, and then we had the common name. Good. Okay, so now we have that. We have a bunch of stuff here now. So we are going to then generate a level 1 intermediate. So this means, a level 1 intermediate CA in Vault. So we're going to take this offline route and we're going to upload it into Vault. So in order to do that, let's see how we're going to do that. Because we're going to have to import it in. The funniest thing is, again, I know how to do this by Terraform. So this is going to be really hilarious because this is like, will it be imported? I don't know. So we'll see. I don't remember how to do this with the import command. Okay, so we want to import CA. Let's grab that. Okay, let's check. Okay, so we're going to import the private key. Important thing that we do need to do is import the certificate and the key first. So we will enable PKI. So we're going to do this. We already have PKI enabled, I guess, right, Melissa?
Yeah.
We could just override it. I guess we could just override it.
Or create a new mount, right?
Yeah, we could create a new mount. So if we do vault secrets, enable space -path equals, you can name it something else. Yeah, you can name it Rosemary, PKI. There you go.
That's it?
Yep. And then we'll probably tune it. Actually, we might not need to tune it. We might just be able to import this. Now let's do vault PKI help, because I don't know for sure. PKI -- help, because let's see. We have list intermediates, verified site, reissue. Can I import? No. Is there a vault import command? Let's see. Does it exist? No. Okay. I guess not. I guess we will have to import. Okay. So let's do this. We're going to have to import the CA information. I wish there was an easier way to do this, but that's okay. Let's see. We're going to import the PEM bundle parameters, PEM bundle. I want the example. I'm looking at the API right now, by the way, for those who are curious as to what is going on. I am looking at the API because certificates to import. It's remembered on console of PKI config CA, PKI issuers import path. This is why when you do things in Terraform, it's so much easier. Hold on, let me check which one it is. Okay, so in PKI connect root. This is enable reset request. Actually, I think it's probably all it needed. I don't actually think we need to. Oh, we do need to CA1, intermediate CA1. Actually, I don't think we need to do anything to it, to be honest. I think as I am looking at this right now, we don't need to actually import it. I think we can just do this, bring it into the self-signed one. So let's see. Let me pull this up. Okay. Because we had because it pull it. Yeah. So if we do vault, PKI issue help. And we scroll up. Is that all that we have here?
There's a lot going on here.
I guess that's all we have. Spent the whole time. It's like, okay.
CA cert.
Mm-hmm.
So we can point to it. And then path.
I mean, actually, I don't think we even need to. We just need to put it into the. I'm looking at my reconstructed how this got done before, and it looks like I just attached it all.
Okay.
So, yeah, I guess that's how that worked. Certificate, sign, cert, connector. Yeah. So to generate the level 1 intermediate. We can use Rosemary. Rosemary can be the level 1 intermediate.
Okay.
So let's do that. And then let me double check what was done. So then we need to do this whole process of set signed again, right? So when you bring an offline root, we're going to have to effectively import the certificate again, right? So we've enabled that. You'll tune, if we do vault secrets tune.
Yes.
We'll tune Rosemary. Secrets tune. Dash default dash lease dash TTL.
All right.
TTL equals, I think we said 365 days. And then max lease TTL, 365 days. And then Rosemary. Yep. Okay. So Rosemary is going to be the level 1 intermediate CA. So the next thing is that we're going to do the CS. We're going to generate the CSR. I think this has to be done manually. We can't use a Vault PKI one because the Vault PKI command, because the Vault PKI command is reading from a root path. So we do have to do all of these steps individually. So what we're going to do is create a CSR. So we're going to do the CSR just to make it easy, I guess. We'll do no, actually, yeah, right. Vault right Rosemary, vault right space Rosemary / intermediate / generate / internal and common space no slash there, so internal space common name, and then we'll call this example with quotes example CA space intermediate authority. Yep. Okay. And then we will do, I think issuer name may or may not be happy, but we'll see. We'll see. I don't think it said no issuer name, right? We weren't allowed to put an issuer name, so maybe not.
Yeah, last time it aired.
Yeah, don't. Try. Yeah, no, it's okay. We don't need it. It's fine. We do need to put, I think, organization. So organization was HashiCorp. I think just to match the root CA, because the root CA was HashiCorp, and then space OU, which is the organization unit. I think lowercase OU.
Oh, okay.
Lowercase OU was community. Yep. Okay. Hit enter.
Look, it's
okay.
Beautiful.
So you do need to save the CSR. I would save all this information just so we have it.
Yeah. Boom.
Okay. Alrighty. Then the next thing we're going to do is, after we've done that, we are going to then, oops, sorry, we're going to scroll back down because we are generating intermediate. Okay, so after that, we are going to sign the intermediate with the root CA because we have a root CA. So we're going to do vault right. Oh, interesting. We don't have the ability to sign the intermediate. Hold on. Let me check because we don't have a backend to sign the intermediate. Oh, we have to do the signing offline. I think that's what happened. Okay, so now we save that CSR in a file. So Melissa, save the CSR in a file.
Okay. Starting from CSR or begin certificate request?
Begin certificate request. Make sure you save that and put it in a file somewhere.
This is the .pem file, right?
Yeah. It's not. It's a CSR file. Sorry. It's CSR.
It's fine.
Yeah. You just put rosemary.csr or something. Yeah. So move it from rosemary.pem to rosemary CSR. Okay. So this is the second piece. Because you are using an offline route, you need to sign it offline. You can't use Vault to do it. So in order to do that, if you go back into your script, the opt vault, whatever it was, something like that. Opt vault PKI offline, I think offline.sh. Yep. If you go in there, there is a command at the bottom. That is how you sign it. We will have to, I think, make some updates, but before you run that command, so copy that command.
Run it. Yep.
You're going to make directory opt vault PKI intermediate.
Okay. Just gonna kill the rest.
Get Control-C.
Yeah. But it's the happy train right now.
Okay. And we might just want to move the CSR into that directory. So we'll just to make it easier because the command. Okay, so then we can move rosemary.csr into opt vault PKI intermediate /ca.csr. And what we're doing is we're basically taking the signing certificate signing request from the intermediate and setting it up so we can sign it offline. So there we go. Okay, hit enter. Okay, so now paste the command again. Okay, so a couple things. This is going to sign the certificate request. So use the certificate request and then sign the intermediate with the root CA. We have an offline route, so it's not like we can use Vault to do it for us. We have to do this manually and then load it into Vault by using set signed. So if you hit enter, yeah, you need to put in your complicated passphrase.
It's not that complicated. I think I just typed it, but we'll see.
Okay, that was fine. That worked. So if you list opt vault PKI intermediate, I love this. Yes, thank you, chat. Yeah, we are indeed it is sometimes a drudge through Vault. So this is why we have this series, because even the people who think they know or somewhat know what's going on still don't know what's going on. So there you are. We have a CA cert now. So this means that we now have a certificate. We now have an intermediate CA certificate that we can use to put it back into Vault, which sounds very complicated, but it is literally this case. So we're going to do vault right, Rosemary / intermediate.
No typing.
/ set - signed. Yeah, before
something
we do this.
Equals at.
Oh, certificate equals at. And
Oh,
then
do I need to be in that directory? I need to be in that directory, don't I?
you could do /opt. It's okay. You don't have to be in that directory. You can just put the file path. So you could do /opt/vault /PKI /intermediate /ca.cert. There we go. Okay, hit enter. And all right. So there's some issue. Rebuild from local CRL rebuild. It's yeah, there may be some issues because we didn't actually do anything that's specific. We didn't actually fill in the certificate thoroughly, but it should still generally get the point across. Which is why I don't think we're going to be able. I don't think we'll show OSPF because I think it's going to be we're just using self-signed certs today, so I don't think we'll have time to use a real cert. But anyway, so here we are. So now that we have this, it means that we can set up the config, right? And then we can set up the roles. So now that we have properly set up the root, it is something that we can now create a role for, and we can configure. So I don't know. Why? I think we're missing steps on this as well. That we didn't actually configure the CRL.
Oh no.
No. I'm looking at docs and I'm like, did we configure did this configure the CRL? And I'm like staring at it. I'm like, I don't think it did.
Vault read Rosemary?
No, I think we're good.
Okay.
I think we're good. It's very strange because I don't think it's actually not in here. That's fine. Okay, we're not going to configure them, but we will configure the role. So we're going to do vault write Rosemary /roles, and then we can do Chris. I don't know, Chris.
Yeah, let's boss Chris around.
Yeah,
seems great.
Issuer _ref equals. We're going to take that issuer, right? So that imported issuer ID, the E12 something.
All that.
Yeah. And then space allowed domains. You can now set it to whatever you want because we never actually set a domain on the certificate. So the original root CA. So, and then allow subdomains true. Max TTL 90 days. We'll do that again. Okay, hit enter. Okay, so now we've configured the role, and then let's issue under Chris. So we do vault write Rosemary /issue Chris, and then we'll do.
Nope.
And then we need the common name. So you'll choose a common name that makes sense because it's getting into Vault. So you could choose subdomains. You could choose no subdomains. Okay. And then I think TTL 30 days. I don't know, something. Oh, is it not allowing subdomains? Fascinating. What happened now? Allow domains getting into Vault IO. Subdomains true.
In the interest of time.
Yeah, just do this. Common name not allowed by this rule. Oh, we have to set a common name. Sorry, okay. That's not even the right common name. Not subdomains. So common name is example intermediate. You could do example.
Oh, right,
yeah, right. I don't even remember what we said. It was example intermediate or something.
It was example intermediate CA. It was.
Mm-hmm. or was it? No, it wasn't. It was if you go to the history, I can't even remember it was. Yeah, so somewhere in the history we had example, intermediate. I'm sure we could probably do vault.
There it is.
Yeah, example CA,
CA
authority.
intermediate
Mhm.
authority. Okay.
Yeah. So let's copy that.
Okay. Fine.
Yeah, this is the we just did this very straightforward. So if you go to the role, and then I think if you configure the role, we don't yeah, you just say like if you configure the role with allowed. Yeah, with that. Yep.
There we go.
No, we have to reconfigure the role.
Oh,
So, yeah.
okay.
Yep. Yeah. So you can ignore the allowed subdomains. Let's ignore that.
This guy. Yeah.
Yeah. And then I don't think. Yeah. Allow. You know what? Just for the sake of time, let's allow any name. So just delete the domain, allow domains, and just do allow any name. We're just going to do this for the sake of time.
Allow
underscore any underscore name equals true. And then delete the allowed subdomains.
Okay.
Yeah, because we are using a common name that is not standard. We're just doing it for the sake of example, but for our offline route. So, all right. So now we should be able to reissue this certificate based on the rule. Yep. Okay, there we go. All right. So within this process, right now we have a private key, we have a key, a certificate key. We also have, if you scroll, it's kind of hard to tell, but there is a CA chain. So the CA chain, if we scroll through the CA chain carefully, we should see a couple different CAs because this is the intermediate certificate. So it may not be complete. You may have to append things in there. There are things when you do an import, you may have to append a CA chain depending on your usage. So when you append a CA chain into bring an offline route, you may find that you have to, when you bring in the, when you set the signed, you may have to set the whole chain, which is the case for most. And you'll start with the intermediate CA, intermediate certificate, and then the intermediate CA, and then the root CA. So, or sorry, the starting from the most intermediate to the root. So you may find that for certificate validity, you may have to import, when you do the signed, you'll have to have a file that has the intermediate and the root CA. So that's not in here, but we are coming up on time. So hopefully this is about as far as we'll cover with PKI. There's a lot of it. I'm pretty sure that we didn't even cover half of it. There's like way more information online about how to do it. We did not cover a transit because I suspected we would take forever to go through PKI. So Melissa, how are you feeling?
I'm feeling pretty good. I'd like to get to a place where we could set this up to automatically rotate for us, but I think that's a future stream, and I'm excited about transit later.
Yeah. We'll figure out transit. I think we'll probably squeeze it into maybe a later one. I don't know. We'll see how we're going to move it around because we got a number of folks requesting performance replication and audit logging. Yeah, but PKI is a little challenging. It's very useful. I think a lot of people who do use it say that it's really helpful for them to manage their certificates, although a bit complicated. There are nuances to doing it if you have performance replication and things like that. Across different regions for Vault. This is on Vault Enterprise or HTTP Vault, but if you have performance replication, there's some nuances to doing it. But otherwise, for the most part, we went through issuing certificates based on a self-signed root CA from Vault, and then intermediate CA in Vault. And then we went to bring your offline root CA and then just set up the intermediate in Vault. And what this means is that you'll just import you'll do an effectively import the root CA into Vault and set up an intermediate CA in Vault. So we went through that. Hopefully this provides some background. Thank you for tuning in. I appreciate the commentary, and I know sometimes it's hard. So if you have any other specific questions, do let us know. We will answer them. With that, we will be back in a couple weeks. Thanks for tuning in to this part, and hope that you join us in a couple weeks.
Thank you.